Hi everyone, depending on where you are, good morning, afternoon and evening. Today we will discuss some basics about serialization and show the types of issues that can be encountered as a result of insecure Java deserialization. So who are we? I am Donovan and here we have Mukhtar as well. Say hi Mukhtar.
Hello.
Yes, Mukhtar is from the UAE. Both of us have our OSWEs and we both of us enjoy web security. And hence, it's quite natural that we decided to pick the topic of Java deserialization. Okay, we will share our handles and our contact later, so in case you want to contact us to find out more, yep, stay to the end. All right. And show the types of issues that can be encountered as a result of insecure Java deserialization. So here, for today, our contents will be as follows. We will first introduce what serialization is, and then we will talk about serialization and deserialization in the context of Java, look at it from the white box and black box approaches, talk a bit about defenses, talk about the current state of research in Java deserialization, and of course, we'll leave some time for questions and answers. So the first question we might ask is, what is serialization? And here we're going to give a bite-sized introduction to it. So here, the idea behind serialization and deserialization is quite easy to understand. And here's a simple example. Often the developer wants to transmit data from program to program, but he can't just drop an object from program A and, just chuck it in program B and hope that it works. So we need to transform this object in some form to a way that I can then bring it across to the other program. So what do we do here? Here, we transform the object to a byte stream and then transmit the byte stream to the network or perhaps to an endpoint, etc., where that byte stream will then be reconverted back to an object. So the transformation from an object to a byte stream is serialization, and another term for this is marshalling. And the inverse, of course, is deserialization, and another term for it is demarshalling. So here, let's look at an example, okay, of application that was presented at AppSec Cali a few years ago. Okay, while this is a very, very simplistic looking application, this contains all that we need to know to show an example of serialization and deserialization. So if you look at the left side of our screen, we have user.java, and you can see that we have a user class whereby it contains the username and role. And as you can infer, you can see that there's an administrator role and a non-administrator role because there is a check to check whether the user is indeed an administrator, right? Note that in the user.java, you notice that it implements serializable. And if you look at session.java on the right side of the screen, so you notice that the developer has implemented some serialized and deserialized functions. So what are they, right? So well, in this case, the developer has decided that, okay, they will find some way to serialize some user, right? And then return this and then make use of this in some cookie value. So let's show how this is being implemented. But before we go there, just to show you later, because we'll be showing a demonstration on this, okay, we have two users, one non-administrator user and one administrator user. The important things here to take note are the names of the users as well as their roles. So Copernicus is regular user and Galileo is an administrator. So just take note of that. So remember we talked about the serialized and deserialized implementations. So we have now expanded it in the session.java file to have a look at the implementation. So on the left, you see the serialization, and if you can pay attention to lines 44 to 46, you see that what happens is that you're actually now creating the byte stream there, and in line 46, you actually perform the actual serialization. Later on, you notice that, this implementation also base64 encodes that byte stream, okay? So take note of that when you watch the demo later. Now you can see that the deserialization function on the right is just pretty much the opposite, right? And here you can see whatever that you were writing, now you're trying to read that object, the serialized object, deserialize it, and then make use of it. So as you can tell, there is quite clearly a problem here, right? Because there is no way we can check whether the objects that are being, not the objects, the byte streams that are being sent to this application to be deserialized are indeed checked for whether they are, first of all, valid byte streams, whether they have been tampered or not. There's no checks, right? So we can see how that goes wrong in our example. So the first example we're going to talk about is this application, and here I'll hand over to Mukhtar to demonstrate this. Okay.
Thanks, Donovan. Let me share my screen. So as Donovan said, there is two Java files. So one is the session and the user.java. So let me pretend that I am typing my credentials to session manager. The first user which has is Copernicus, and the second user which is administrator is Galileo. First, let me try with Copernicus. And his password is Poland. So I'm successfully authenticated, and this is my session cookie. And let me try to like pretend that I'm going to submit this session cookie to my web browser. So as you can see that it's welcomed back to me as user Copernicus. So let me try for us administrator user as user Copernicus. So let me try for us administrator user. His password is Italy. So now it welcomed back as Galileo. This is my session cookie. So now it welcomed back as Galileo. This is my session cookie. But it's this time it's saying I'm administrator. So let me analyze this Galileo session cookie and try to fix it how I can analyze Galileo session cookie and try to fix it how I can analyze. So what I'm going to do is I'm going to paste 64 it and save it to as cookie.ser. And I'm going to open up in the hex editor. So if I analyze this one, I can see that some string is regular. So let me change it to administrator. Administrator. Now I'm out of room, so I need to switch to insert mode. Administrator. Of course, administrator is different, longer than the regular string, so I need to change it this byte from 7 to D. Save it, and I want to. Now this time I want to feed it to my session manager. Save it cookie.ser. I need to use this parameter to not to destroy the string. This time is welcomed back as Copernicus, which is regular, but as you can see, I have an administrator right. So this is happening because of the session is not checking the value integrity of the byte stream. So if security wise, so if we have some kind of private key, we can encrypt it, and so it will check the integrity of this byte stream. So now this is the end of example. So Donovan. Donovan, you need to unmute it.
Yes. Okay, let me get back to the slides. Right. Okay, share my screen once again. And let's go. All right. So you have looked at an example of insecure deserialization in this case because of the lack of checks. Well, you can basically fool the application into thinking you're an administrator when you're not. So that begs the question whether serialization is useful or not, because if it's so problematic, do developers use it? But the answer is yes. And the reason is that serialization is important because, for example, I want to send an object to a remote application by RPC, or sometimes I want to send some data to an API. And the way to do this is to transform that into a byte stream, into something that the other program can understand. Like, for example, if I want to send something from a Java program to a .NET program, you realize that I cannot just take the Java object and throw it to .NET and hope it's all okay. So serialization is indeed useful. So we cannot just decide to chuck it away and say, let's not serialize or deserialize data. So one example in which this is useful is in the conversion of objects to data formats that are universal, such as JSON or XML. So in the case of .NET, you see that we can implement XML serializer if you want to pass an object using XML, or a JSON serializer if you want to pass your object using JSON. So as you can tell, there's a slight difference from the serializers that we were talking about in the first example, where we use a native Java serializer and deserializer. And here you are serializing into a more universal format. So just take note of that. As you saw just now, deserialization can go wrong. Like in this case, if the deserializer deserializes user control input that we can just, amend at a whim and fancy, you can see how that can lead to application vulnerabilities, right? And also Mukhtar mentioned that one way to deal with this is, well, you make sure that your user control input in this case needs to be signed, such that, you cannot just temper one parameter and do what you want to do. But of course, you can do more than just that. And the summary of all of these is that if you pass the correct strings to the application, and you can make use of certain code within the application to do certain malicious things, you can perhaps write a shell or execute malicious commands. But in short, RCE is possible with insecure deserialization. And even if we cannot achieve RCE, there are some interesting denial of service attacks that can be carried out. And if you look at the link below, he gives basically some payloads that you can use to check for these denial of service attacks that you can carry out against application that employs insecure deserialization. And this is just a slide in case you have laymen amongst you that don't know the severity of deserialization, think is something exotic. You can tell them that, hey, this can potentially carry the maximum CVSS score. You're talking about RCE here, and so you are dealing with a vulnerability that is quite severe. So before we carry on about describing more about this, just to take note that deserialization is not exactly a very exotic thing, even though it was only recently on the OWASP Top 10 in 2017. These have become well documented over the years, and I think if you are familiar with Potswigger Academy, you might have already encountered this page. But the long story cut short is that knowledge on this is quite commonplace nowadays, and so you can no longer treat this as, say, something that is quite exotic, hard to carry out, etc. There's a lot of open source information about this, and one of the objectives of this talk today is to show you where to look for all of these information. So without further ado, let's jump in specifically into Java. So a bit of a historical background of how all of these started. Some reference talks for you in case you want to trace the history of Java deserialization exploitation. In 2015, Gabriel Lawrence and Chris Frohoff presented quite an interesting talk on Java deserialization titled Marshalling Pickles. And then this was followed up with 2 more talks by Alvaro Munoz and Christian Snyder in 2016. If you Google names such as Chris Frohoff and Alvaro Munoz, these are essentially household names when you deal with the deserialization research in the field. So you can just remember these names, you Google them, and I'm sure you can find lots of reading material to entertain yourself with. And well, that's the historical backdrop of how Java deserialization pretty much caught fire, and well, security researchers started to work on it on all sorts of applications. How bad did it go? Quite bad, as you can tell, because you see that Java deserialization flaws were found in all sorts of big vendor applications, including in Java libraries, etc. So the point here is that, well, maybe one fine day, if you're pen testing large organizations, applications, perhaps you might be one of these people who find a 0-day and, well, be able to write about your journey of discovering and exploiting a Java deserialization vulnerability. They are there, basically. But how is serialization being done in Java? So remember in the first example, what we made use of, it's a native serializer in Java, right? But take note that Java serialization can also take on non-native, can also be implemented through the use of libraries, okay? But before I go on to that, let me just talk about some of the commands that you may want to take a look at if you are dealing with the Java native serializers and deserializers. Namely, the second set of bullet points where you look at the write object, write replace, and write external methods for serialization, and deserialization, the various read methods. For non-native serializers and deserializers, you probably want to take note of the various frameworks that we have, okay, such as Spring, RMI, JMX, etc. So the point is that when we are doing code review and you're trying to figure out, like, say, okay, I want to exploit a Java deserialization vulnerability. I need to discover where the deserializers are located, right? Where are they? You need to look out for, first of all, are there native deserializers being used? This isn't too hard to find. And you should also pay attention when you decompile your Java application to the different components, the different libraries that the Java application uses, because then you will need to read up, like, okay, say you use a certain library, what kind of deserializers are being used. Okay, and there are plenty of resources for you to check on that. Like, for example, the OWASP Java deserialization cheat sheet. Okay, so without further ado, I would like to hand over back to Mukhtar, who will show an interesting CV that was discovered this year that deals with Apache Tomcat and how you can exploit deserialization to achieve RCE. All right.
Thanks, Donovan. So we are going to present the recent CV 2020-9484, which is found in Apache Tomcat remote code execution via persistent manager. So first thing first is Apache Tomcat is the HTTP server for dedicated for Java. So in Apache, Word Manager will describe like how the session component. So in Apache, it has two implementation of session management. One is the standard manager, and the second is the persistent manager. And depending on which implementation, it will save your session information how and in which format. So we will see the configuration of the. So to implement the persistent manager, we need to have we need to set up the idle swap time and where it's exactly is located the session information. So within set, let me jump to my VM. Here we have a vulnerable Apache Tomcat. We already set up, so it's just a generating session information. So let me jump to the Burpsuite. So what if I send it to backend server, so it will just give me session ID. And what if we, this is a session input which is handles, which is user can handle. So user can send any kind of malicious input to backend server. And here we have the backend server, Apache Tomcat, and we already copied some serialized object, which is Mystikcon. So Mystikcon information, let me show what exactly this file. So we already know the hex editor. So if I analyze this, what kind of information? So what we are doing is here, like we are executing command, touch command to write in the temp folder. So if you can see, just a moment. So we are using the touch command. Here, as you can see, we are using the touch command and to execute this at the backend server Mystikcon. So here is my backend server. As you can see, we don't have any kind of file in the folder of temp. If we send a backend server, this user controlled input JSON.id. So we are just locating to user local Tomcat and the Mystikcon file. So we are executing and we are getting the RCE at backend server. As you can see, we have already executed that backend server. So what's happening is at Apache Tomcat, so it gave us 500 error, and on stack information, in blue code is it's trying to first of all it's checking that session exists or no. If session is not exist, so it's checking the file disk, and it located at Mystikcon.session, and it's trying to deserialize it. So once it deserializes it, so it's executing the command which is touch. So basically, it has a risk score 7 because of low likelihood. There is some pre-requirements required, like system administrator, Apache Tomcat administrator needs to implement persistent manager, and also we need to have some kind of upload functionality where we can locate our payload. So, Donovan?
All right. Okay. So you might have. So you, after looking at the demo, you might wonder what black magic you were looking at, right? So let's try to debunk some of these and try to present to you in step by step what's going on. First of all, for Java deserialization, we need some ingredients. Okay. So what ingredients do we require? First, we need a deserialization command that emits untrusted input. Like for example, if you're trying to exploit the native Java deserializer, you want to exploit like something like read object, okay? Next, you also need to find a location to pass untrusted input to deserialization command. Like for example, could it be a parameter that the user controls directly as part of a post request? Or maybe it's somewhere more indirect, okay? But the idea is that first I need to be able to control some input that gets deserialized insecurely by a deserializer, okay? And next, after all of this, right, even if you deserialize said user controlled input, this user controlled input needs to be processed somehow, okay, by some other gadget that then executes code dangerously, right? So in short, you're looking at these key ingredients. So now you might wonder, what's going on? Does this sound familiar to some of us? Actually, they are. Essentially, what we are thinking of is a gadget chain, okay? And if the exploit developer and you answers that you're going to do something related to rob, yes, that's exactly it. So the idea is that we're trying to find a gadget that executes after deserialization, look at the code to look at what are the intermediate gadgets this input goes through, and then at some point execute what the attacker desires. Like for example, if it's writing some of this input to somewhere in the web root, then we will ask, okay, can I write the web shell, right? Or say, for example, if I'm executing a system level command, can I then pass a certain command to let the application execute it, okay? But now you might be wondering some questions, okay? Like for example, okay, yes, you talk about parameters, so where to find this? So it could be in this case, if you look at example 1, right? We decided to deal with the deserialization vulnerability by basically adjusting the cookie value, in that case, the session cookie. Sometimes it can be some innocent parameter that the application passes, right? We'll talk about finding such parameters later. Now, the question that you probably be wondering is, okay, I'll probably have to do lots of code review. And, you know, if you did ROP before, you know that these gadget chains will have to be done differently depending on, say, the kind of application that you're exploiting, right? So now, do you have to build or find the gadgets ourselves? That's the question that you might be wondering. Unfortunately, for the developers, and fortunately for the attackers, the answer is not really. You can find pre-built gadget chains. And must the code be used by the application? Not really as well. As long as you can access the code somehow, even if the application isn't actually using the code in production, it's fine. So the idea here is I'm basically living off the LAN, in this case, the vulnerable application, making use of the code in the vulnerable application to do something that the attacker wants to do. Without further ado, let's talk about a very simple example of a gadget chain. So here, we have, now I took this example from another writer that talks about Java deserialization. You can see the URL at the bottom of the slide, okay? And they provide quite a friendly explanation behind gadget chains. So let's look at it. So here on the left, you see a session class that contains a load session method. And notice that it accepts an array of bytes and then sifts out 2 parameters, as you can tell, the username parameter and the logged in parameter in line 7 and 8, okay? Something that you should be aware of is line 6. So you see there's an object input stream. And if you search the Java documentation, you see that you are dealing with a deserializer. So here we have a good start, right? Because now we have one ingredient, that is, we're going to be deserializing something. Next, let's look at the code snippet on the right. So we have another class called user settings controller. And you see basically it deals with some sort of session management. All right. Here you see that the username parameter in the user settings controller on the right is taken from the session class and will be stored if the user is logged in. So you can look through the code, you see that a session is logged in, you update the user model basically with the session username, new password. You get the idea here, right? And in other words, if you control basically some byte stream, okay, that is then deserialized by object input stream in the session class, okay, and then you happen to be logged in, you can prepare an arbitrary string that will be saved in the username parameter and be passed to user settings controller. Okay, so here it's a very simple looking example. Sometimes the gadget chains can be quite long, but the idea here is to show you what we mean by when we talk about a gadget chain. Okay, so remember we talked about finding where we could inject some of these payloads, so let's talk about that. So if you paid close attention to the first 2 examples, we glossed over this a little because what Mukhtar did was to basically amend the byte stream directly. Here you can tell that once you want to hunt for these serialized objects, you can look out for what we call magic bytes. And what are magic bytes? Well, to tell Java that they are dealing with a serialized object, these objects are basically marked with certain set of bytes. So you can look out for ACED, and 0005 shows the version of, say, the Java serialization data that you have there. So magic bytes. Sometimes application developers will base64 encode this anyway, so you can look out for the base64 encoded version. Also, telltale signs if, say, for example, if you see something emitting Java serialized object in the content type, you can tell quite clearly it's a serialized object, okay? And if you remember the examples that we did in example 1, you remembered that, well, what Mukhtar did was to basically change the regular user to that of the administrator. So as you can tell in byte stream here, you see that some of the information that you have is still in plain text. And so sometimes it's just as easy as just amending some of these plain text, getting the correct answer and following the application logic. But then you might ask, okay, following the application logic is something that we do all the time, but can we try harder? Well, before I answer that question, let's talk about gadget hunting and construction. So throughout the talk, we have been talking about native Java serializers and deserializers. But in actual fact, once you talk about other non-native serializers and deserializers, trying to hunt for these gadgets and constructing them can be some, okay. So, okay, let me repeat this. Okay, let me go back. So remember we talked about native serializers and deserializers. So what happens when you deal with non-native serializers and deserializers? So here we have a Java deserialization cheat sheet. So for example, if you find a non-native deserializer, okay, how do you find said, like, you know, like magic bytes for that case of the deserializer that you are trying to attack? So if it's like, for example, JSON.io, JSON-IO or Jackson or whatever, you find the various deserializers that you use, and this cheat sheet will tell you what to look out for. So basically, the information is out there. But before I talk more about this, let's finally introduce to you something that you should probably have heard before once you hear of deserialization vulnerabilities, and that is our good old friend YSO Serial. YSO Serial is useful for us because basically this whole gadget chain construction thing is simplified by YSO Serial. So basically YSO Serial can be used to generate gadget chains for a variety of, say, different Java deserializers that you'd like to attack. So I shall leave this to you to go and read out more on what you can do here. Once again, you see on our picture, you see Chris Frohoff's name, right? So indeed, his name is a household name in Java deserialization. One thing to add about this is correctness. So sometimes when you try to attack Java deserialization vulnerabilities, you might get error messages, for example, casting errors, because the objects that you may try, the byte stream that you have, that you try to deserialize may not actually deserialize properly. But the truth is this, objects in the serialization stream, okay, are instantiated as they're loaded, meaning to say you don't need to wait for the whole byte stream to be passed through before you can get any sort of code executed. So in that case, even if you get errors, you should also you should check whether your proof of concept has indeed worked. So in the white box scenario, this is quite easy to check for. But without further ado, one more example, and here I will hand back to Mukhtar to show some custom gadget chains that you can do for Java deserialization. Here he will show something quite interesting. So let's hand over back to him.
Thank you, Donovan. So basically example 3, so we took it from the web application. It's just a simple web application which has a serialized object in the cookie. So first thing first. So I'm just going to log in at web application and see the so as you can see we successfully logged in, and as you can see the in session serialized object, so serialized and the base 64. And also if we see the folder backup, we can see that there are two files. If we analyze both of them, we can see it's handling the session token and it's serializing to get the information about ID. So let's see so this is the access token user, and we can see that it's extracting the information and passing to the product template. And what it's doing is here is it's serializing, and it's constructing the Postgres query to backend server, and it's sending to backend server with the user controlled ID. So what we can do is we can try to extract, try to generate serialized object which has Postgres command query. So for that, we can just create a new Java application, which can do is what it can do is it can serialize and it send our payload. So we have a video for that. You can see it's a serialized object. We can analyze it using the known tool is a hex editor. Basic64 decoded and saved to file, and we can analyze the serialized object. As you can see, it's a serialized object which is serializing the token. Constructing the backend server Postgres query. So as you can see, it's just getting the information from products based on ID. Try to inject our payload to this ID field. And for sake of the POC, we can just slipping to backend server, Postgres. Injecting our payload. So we just compile it and get the serialized object so we can inject to our session. Got a serialized object, and we can try to inject to session. So what it will do is, so it will basically sleep for 10 seconds. Basically, is what it's doing is so it's deserialized, so and it will execute from the session cookie and it will execute the SQL injection query. So next thing is what we can do is we can try to more advanced exploitation. So we can dump from the from backend database password of administrator.
Don't harm on the beats.
So we are using the union query to write columns, compiling and getting the serialized object, and we can inject to session value. Goal of this web application task, so we can get the password of the administrator, login as administrator, and remove the user. So once we delete it, so lab is solved. Basically this, Donovan, if you can continue the.
All right, so if you had watched the Java deserialization dance there just now, you can see that basically you can cause quite a lot of damage. But there are some limitations and caveats to this. Like for example, if the application cannot access said class, then well, there's nothing that you can do about it, right? Now, second, of course, is that these gadget classes need to implement serializable or externalizable, meaning to say when you search for, say, the parameters that you're trying to attack, you need to look at the implementation. All right, like for example, blah, 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 implement serializable. Okay. Minor thing about the gadget chain, sometimes different versions of the libraries have been implemented could result in slightly different gadget chains. And well, one point that you should mention that is quite important is that nowadays, when we pass important parameters, we are not going to be passing it in like clear text or base64 encoded strings. So finding magic bytes is not going to be so easy. Okay, even if you happen to find them, these could be signed parameters, meaning to say that, okay, you can try to adjust that. And then when you pass that attack string, you realize that, hey, the signature doesn't match what you passed, and then basically the attack fails. Okay. Now, but throughout the talk, we have been discussing from the context of a white box perspective. Basically, we know something about the code. What happens if you don't know any of these things? Which is basically the black box approach. The good news for attackers is that black box doesn't darken our hopes, and let's explain. So there are pre-built gadget chains that exist, and if you recall what we mentioned in our talk, well, YSO0 comes to the rescue. More than that though, if you're a pen tester and basically, you are looking out for Java deserialization flaws from a black box perspective, there are some Burpsuite add-ons that can help. Like for example, you can make use of Freddy or Java deserialization scanner, etc. So the point here is that even if you don't know what the underlying code is, you might be able to find some of these scanners that can help you deal with like perhaps trying your luck to see if, say, okay, I find some parameter that has magic bytes. You try to, send a whole bunch of different payloads and see what works. Though we'll mention some problems with that approach later on as well. Remember, we mentioned that there are all sorts of Java serializers and deserializers out there, native, non-native. Well, sometimes you get these answers through other errors or other, vulnerabilities in the web application. Like for example, if there's an information leakage that leaks, for example, the libraries that they use or the frameworks that they use, well, you know that you can narrow your search space of the serializers and deserializers to a narrower range. And when you try to fuzz a certain, parameter, you don't need to fuzz as many values. So that helps an attacker, right? Well, because it's black box, there are limitations. So let's discuss some of these limitations as well. Well, if you have no access to testing instance, no popping calculators. We know that popping calculators is a favorite for exploit developers, but there is no calculator to see. And you probably also don't know the level of permissions in which the application is running. So for example, if you're attacking something that's running with a low level privilege user and you try to send a payload that adds an administrative user, then that's not going to work, right? But you can always write callbacks. You can always write some payload that says, okay, visit some web server somewhere and take something. So cough cough burp collaborator. You get the idea, right? Now talking about tools, we mentioned about scanners. Be a bit careful when you deal with these scanners because many of these scanners flag positives by sending sleep payloads, meaning to say, as what Mukhtar demonstrated, you send some payload to tell the application to not respond for some period of time. As with sleep payloads, you know the problem with false positives. Basically, you don't know if it's indeed a finding or well the application just lagged or ran out of memory or whatever. In some weird cases, okay, it's possible to crash an application with YSO serial payloads. It has happened. Bad if it's not so good news if you wanted to play more with the application. Since we are on the topic of black box, we'll talk a bit about fuzzing as well. You will encounter error messages sometimes, and we can make use of errors to tell us whether we should go any further. First error that you likely find, class not found. If you find that there isn't much hope because there's no class to deal with. If there's no class to deal with, basically your gadget chain is going to fail. But if it's an IO error, then you have some hope. Basically, what happened is that, hey, your input doesn't seem valid, but we are trying to process it. And in that case, then you can start wondering, okay, maybe I should change the payload. Maybe, for example, I was trying to fuzz for, say, a certain deserializer kind, then they realize that, hey, the payload doesn't really make much sense to that, but I can change that, okay? And in the worst case scenario, if you really think there's a deserialization vulnerability, I guess you can just spray gadget trace and pray. Not a good idea, but always the last resort. Now that we have talked about the offense, let's talk a bit about the defense against the dark arts. Because after all, pen testers and security researchers aren't paid for just attacking systems. We are paid to solve these problems as well. The first golden rule is to stop deserializing everything that you see. Basically, you need to tell the, you need to limit what you're deserializing. And these suggestions, you can find all of them on the OWASP deserialization cheat sheet. So I'm going to just summarize these recommendations. The key idea here is that you're going to limit the types of input that you can deserialize. Like for example, if you mark read object with final, you're not going to be able to adjust it on your whim and fancy, okay? But I'm going to talk a bit about the fourth point in particular, because the fourth point is important. Avoid native deserialization formats. And the reason for that is because the default object input stream, for instance, if you read through the documentation, doesn't check for the byte stream that you pass it. Basically, it attempts to deserialize anything, which means to say, if you are implementing a deserializer, you will want to find something that will check what kind of objects you're going to deserialize before you will try to do so. So that means, for example, if you pass something that's an invalid object, you're just going to tell them, hey, this is something that I can't understand. Well, I'm just not going to deserialize this, instead of actually trying to do so. You can tell this, okay, then also, the last point about hiring your own serial killer. So as per web application vulnerabilities, there's always the framework approach, meaning to say, okay, if we need to deal with a certain vulnerability class, why not find a library to deal with it. So there are such libraries that mitigate Java deserialization vulnerabilities as well. And one such example is that serial killer library that I've shared in the slides here, right? But all in all, for all that little discussion that we have, the most important thing that I will have to mention here is that it's the unsafe deserialization where the vulnerability lies. Meaning to say, you shouldn't blame the gadget chains, you shouldn't blame the gadgets in your application because, well, your application likely uses these gadgets in the first place for legitimate purposes. The problem should always be solved at the deserializer, all right? Well, then of course, some people will say, hey, is it like type juggling in PHP where if I don't use PHP, I'll solve the problem? No, in this case, deserialization happens in multiple programming languages. This is not a language-specific issue. You can see this in Ruby, Node.js, .NET, PHP, etc. So it is not so much about the language, it's about secure coding practices, okay? Before I end, I would have some extra resources for you that you can look at. Practice labs in case you want to have your hand at practically practicing your deserialization skills. There are a few example labs that you can look at. Deserialization Lab and of course Portswigger's Web Academy, Web Security Academy has some specific examples. Speaking of Java deserialization, no talk is complete without talking about what has happened recently. And the truth is, many things have happened this year besides COVID. In 2020, what happened is that you see that Java deserialization vulnerabilities have been found in other applications as well, and some even in response to say a Black Hat talk that was covered earlier earlier last year, whereby they talked about how you deal with some of these Java remote protocols, understand it, and basically pass deserialization payloads through that. So that is particularly interesting to look at. And also, if you don't happen to deal with Java and you happen to work in other programming languages, I encourage you to do your own research on the different programming languages. I personally find the .NET deserialization vulnerability news quite interesting, and some of the security research that has been presented on that topic quite illuminating to read. Like for example, the attacks that you have on various Microsoft products. So as a parting note, what we have hoped to achieve in this very short 50 minutes is to entice you into the richness of deserialization vulnerabilities that, well, that's a good reason why it became Overall's Top 10 in 2017. And well, as always, there's always the question and answer section and the contact us page. So if you would like to find out more about what we do, or why we decided to give this talk, or to explain some aspects of deserialization that we didn't explain too clearly in the talk, please feel free to contact us. You have multiple contacts, and since these slides will be distributed as part of Mystikcon as well. So thank you very much for your time. I will leave this slide here for you in case you want to take note of our contact details. Right? So if you have any questions, I think for those of you who are watching on Twitch and YouTube, you can ask us there as well. All right. So too clearly in the talk, please feel free to contact us.
Yes, this was the talk about serialization. We have 7 minutes left, so if there are any questions, you can ask them right now.
Yep.
You can ask anything you want about serialization, of course. So yeah, let's wait.
All right.
Yeah, how did you guys like the talk?
It was good, Donovan.
Yes.
I want to say that sorry for that if I go slow or if I go fast. So it was first talk.
No worries.
Yeah, everybody started somewhere, so yeah, it's just a learning process. We all want to learn. So are there any questions from the viewers? We have 5 minutes left, so plenty of time for questions. If there's something you you don't know, you didn't get the point from one of the slides, just ask it. don't be afraid to ask, because you will learn. I hope.
Yeah, and one more thing. So we can share our slides and the video in somewhere public, so
Yes.
everyone can get these slides.
Yes, the session will be is recorded, and it will be yeah, uploaded to YouTube next week once the editing is finished.
Yep.
I see there are no really questions. But
No
yeah.
questions, all right.
No.
So I guess since we have a few minutes, maybe I'll just because you realize that we made this talk fairly fast-paced, and that's simply because of the nature of deserialization. It's just a lot to talk about, and lots of exciting research that there is, and I guess we decided this is just a bit of behind the scenes, right? So we decided to pick Java simply because we thought it was something that it's more accessible to our viewers, and since it's a Deserialization 101. But in fact, some of the most interesting deserialization vulnerabilities that I read about actually deal with .NET, because you look at how you make use of deserialization, and because of how the .NET framework is integrated with the Microsoft internals, you can do even more interesting things. So I think there was one article that I read, I think, where there's this unauthenticated deserialization RC that I think those who are interested who should read. Basically, they attacked, I think, Exchange, if I'm not wrong. It's somewhere this year. Do you remember this, Mukhtar? If you happen to remember when exactly they published this one.
I believe it was in the beginning of the year, so it was.
Yes. Mm.
Well, if you can share the article in the Twitch or YouTube channel. And I have one question.
Okay.
What do you think about non-Java deserialization?
Non-Java deserialization. Is that... Short answer, it happens. So just because today's talk is on Java doesn't mean you shouldn't worry about this if you are not in Java. Though I may want to add a bit about a certain language. So if you have listened to talks about PHP deserialization, frankly speaking, the only words I can say about PHP is that, the native serialization format and deserialization format is nonsensical. Basically, all it does is to convert it into something that's equally human readable.
Well, that is why we call him Mr. Sunshine. He's always Lachin. But yeah, I hope that answered your question, Frosty12. And yeah, I see it is time to move on.